This video will show you how to create all the data tables that you'll need for the lab and the graphs that you're going to need for the lab. Um, the first thing you can see here is I've opened this up in Microsoft Excel. The coding and everything should work exactly the same in Google Sheets, and you'd be able to share that through Google Drive. You could also share through OneDrive the Excel with your partner. So either of these should work, and you should be able to both be working on it, both have access to it. What you can see here, just to save time, I've typed some things in up at the top. And one issue you might have at the beginning is that the words won't fit in the box. So one thing you can do, you can click and drag it out. But also, if you just double click in between these lines, so you can see click between B and C, between C and D, so on, it will auto size the boxes to be the proper width needed to fit all of the writing in there. So everybody should look like this. The thing that'll be a little different, where it says your units, put whatever units you measured in for your ticker tape. So just in the sample one, I'm going to use millimeters. So I'll put in millimeters, and I'll just resize that again by double clicking. So I'm just going to put in a couple numbers, just sample numbers, and we'll just say I went up by, and it changed by about the same amount every time. Okay, so you'll have more numbers than this. You'll probably have about 30 numbers or so going down the side, but this will be enough to give you the general gist of what's going on. So the next column that you're going to fill in is going to be your change in position into meters, because we want to get our acceleration in meters per second squared. So what you're going to do in this case is do a equation right in Excel. And to do that, you're always going to start with the equal sign. So you can see I typed in the equal sign right there. And whatever mathematically you need to do for your conversion of whatever your units were to get to meters, you'll type that in. But instead of dealing with 5 or just typing that, I'm going to click the box. So in the case of getting from millimeters to meters, I need to divide by 1,000. So I'm going to click this box, and then I'm going to just type divide by 1,000. So that's the division symbol there. When I hit enter, you'll see that pops up in the number. Now, I could type that every single time for all those numbers, but that's a lot of extra work that you don't need to do. Because if I just click this box, right, and see I just clicked it when it's that white cross, if I go down to the bottom corner here with this black cross and click and drag it all the way down, it's going to do all of them. So we can see, because instead of doing 5, I did A2, well, this one does A3, and this one does A4, and this one does A5, and so on. So it just changed all the values there. All right, we can do a similar thing with the time. So we know the first time is 1/60th of a second, which is equal to 0.01666 repeating. So I'll just throw a 7 in there at the end. The second time would be 0.0333 repeating. So I'll put that in there. Now, if you want to count up by the same amount every time, I can highlight these two numbers right here. Okay, so all I did was I clicked on one, held it in, dragged down to the other one, and go to the black cross, drag it all the way down, and it's going to go straight through and fill this out. Now, as you get down to the bottom, it will become slightly off just because these numbers are rounded, but you can see like this number should be 0.2 and it's 0.19999. So it'll get you close enough. It's going to be fine. If you want to be more accurate, just put some more 6s in there before the 7 and just put in some more 3s. To do the cumulative position, okay, first thing, just take that first change in position right here, the 0.005. All right, now if I want to find my cumulative position, what I'm going to do is add the position that I had before plus the new, or plus how much it changed by. So when I hit enter, I get that new value. And again, I don't have to do this every time, because instead of putting 0.005 plus 0.03333, I did D2 plus C3. So it knows that anytime I click and drag, what it's going to do is it's going to add the box that was above plus the box to the left. Like if I look at this one right here, I can see it's adding D5, which is right here, plus B6, which is this one. So it's always taking the position I had plus the amount that changed by. So this is going to very quickly give me my cumulative change in position. Okay. what you can do at this point is make a graph. This section right here is going to be all the data that you'll need, and you're going to make 3 graphs. One will be a position time graph, one will be a velocity time graph, and one will be an acceleration time graph. So you're going to see all these right here. To make a graph, highlight the numbers that you want, and if you set it up this way, it'll always put them on the right axis because we have time first, which is then going to go on the x-axis. Time is first, x-axis, time is first, x-axis. The way you'll make the graph, click Insert, go over to these dots, which is the scatter plot, and click the one without anything. Okay, you can label this right away. So there's a title section. We can make this position versus time because it's a position versus time graph. There's 2 other things you're going to need to add. So when you click on the graph, this blue plus sign, add a trend line and add axis titles. So in the axis titles, on this side we had position, and that was in meters. And then down here we had time, and that's in seconds. So that's all my axes labeled as I need them to be. But looking at this trend line, we can see this is not a trend line that matches the data because we have a curved position time graph, which makes sense because there is acceleration when something's falling, but the line itself is linear. So if I double click this line, I can change it to a polynomial function, which is a squared function right here. And I can also click Add Equation or Display Equation on Chart. So now what I have is a position time graph with the axes labeled, with the best fit line and the equation for it. So I can put that just right down here. You can slide it out of the way. And you're just going to keep going. Now, the key thing to understand for the time of the velocity is that you need the average time of these two, because this velocity that you're getting between your 2 points here is actually is giving you the velocity halfway between these points. So if I want to do that, the way I'm going to find average is I'm going to add these 2 together, and I'm just putting it in parentheses because I'm going to divide by 2 and I want the addition to happen first. Dividing by 2 so I can find the average, so that's my value. Again, you don't have to do this every time. Just click and drag straight down. What you'll notice, all of these make sense except this last one, because it's just taking the average of the last number. We can look, it's taking the average of C13 and C14. So this and this, which is empty, so that's not going to be there. And remember, anytime you're going back to a motion diagram, you always had one less velocity point than position. You always had one less acceleration than velocity. So when you do your acceleration, you're going to be missing those spots as well. You're going to have to figure out the velocity. Remember, the equation for velocity is delta D, so the change in the position divided by the change in the time. So I want you to try to use, for the change in position, figure out which of these you'd use, and the change in the time, figure out which of these you'd use for the equation. And then time for the acceleration. When you do the time for the acceleration, you're going to need to take the average of 2 velocities to figure out the time for the acceleration. And then to do the acceleration itself, you'll have to use the equation for acceleration, which is delta V divided by delta T. So the change in the velocity divided by the change in the time of those velocities. Okay, again, for your velocity, this many will be filled out, and for your accelerations, you're going to lose one, so this many will be filled out. Just like you have a position time graph, you're going to have to create a velocity time graph and an acceleration time graph. Both of those graphs should be linear, so all you'll have to do is title it, title the axes, add the trend line, and display the equation. You won't have to change it to the polynomial. It's already linear, and you'll just leave it at that. Okay, so that'll get you through collecting all the data that you need and making the 3 graphs, and then you can advance from there based on what I tell you to do next. But try to think and figure out how to fill out these last boxes. For these first 5 columns, you can just follow exactly what I did. Only difference might be how you changed your unit conversion based upon what you measured in.